So this piece really lays out that core tension in AI development today. You've got the blueprint for success on one hand, and then the hard reality of structural failures on the other.
This is fantastic. I mean, you haven't just given us a list of best practices. You've immediately jumped to the high-level challenge.
Right.
And including that counter-argument from the start, it elevates the whole discussion. We're moving past the how-to manual and straight into the philosophy of AI risk.
It sets the stage perfectly. But I think to really maximize the impact here, we need to stop treating the blueprint and the counterargument like they're in two separate corners.
Hmm.
The next step has to be synthesis. And that starts with how we actually think about failure itself.
I couldn't agree more.
So the material would benefit from a synthesized framework, distinguishing clearly between process failures and inherent structural limitations in AI development.
Okay, let's unpack that.
You've done a masterful job laying out those foundational blueprint principles. Things like rigorous testing, clear goals, high-quality data.
The essentials.
Exactly. And you correctly point out that projects fail when teams just skip those steps. But then the counterargument drops a bomb like IBM Watson for oncology.
Right, where they had massive data sets, leading experts. They seemingly did everything right.
And it still failed catastrophically.
So the weakness, I think, is that these two ideas, the ideal process and the messy reality, are sort of kept in separate lanes.
They are.
And that misses a huge opportunity to integrate them into one unified theory of risk. We need to categorize where these failures come from. Are they, preventable through better discipline? Let's call that process risk.
Okay.
Or are they basically non-negotiable because they're baked into the world or the complexity of the system, and that we'll call structural risk?
So the suggestion here is to introduce an actual structured model, a way to map the principles from your blueprint directly against the structural flaws from the counterargument.
Yes. And if you do that, this paper stops being just a list of successes and failures.
It becomes a predictive tool.
It becomes a powerful framework that tells you which problems you can engineer your way out of and which ones you just have to mitigate because they're part of the landscape.
Let's make that really concrete with the examples from the material.
Okay, we should absolutely use the Amazon hiring algorithm as the poster child for structural risk.
Why that one specifically?
Because the data was, from a technical standpoint, clean. It perfectly reflected who Amazon had hired in the past. The problem wasn't the data processing.
The problem was the world.
The problem was the world that generated the data was already biased against women. You couldn't fix that with a better algorithm. The bias was inherited, baked into the source material itself.
That's a really sharp distinction, but I do have a question there. If we label a failure structural risk, are we just giving developers an intellectual get-out-of-jail-free card? Does it lead to a kind of fatalism?
That's the tension. That is the exact tension the piece needs to address. Classifying it as structural risk isn't about giving up.
Okay.
It's about recognizing the solution isn't a simple software patch. It's a systems problem. It might require ethical mandates or totally new ways of training that actively fight against historical norms. You treat the risk as an input, not as a bug.
I see. So to really drive that contrast home, we then use the other example, the early faulty hospital diagnostic AI.
Exactly. That one failed because it was only trained on data from suburban patients.
So it was misdiagnosing urban populations.
That is textbook process risk. It was a clear, direct failure of the diverse and representative data principle. It was a preventable mistake.
And it was fixable.
It was completely fixable by retraining it with a better, broader data set.
So the action item here, for the listener, is to actually build a matrix. You take each of your blueprint principles on one axis, and you test them against the hardest structural counterarguments on the other.
Mm-hmm. And that fusion, that's what turns this document from a good analysis into a really sophisticated tool for thinking about AI. It's a huge conceptual leap.
And if you start thinking about failure being baked into the data, our structural risk, it naturally raises a huge question about the human element.
The experts.
Specifically, how does world-class expertise fail when a system is just inherently chaotic? Which brings us to our second point.
The material needs to further explore the failure modes of domain expertise when applied to nonlinear and chaotic AI systems.
To be clear, You make a great case for interdisciplinary collaboration. You've got fantastic examples. Developers and radiologists, technologists and environmental scientists.
Even the use of experts for something standard like a cloud migration. It's obviously critical for getting baseline things right.
But the blueprint section treats expert collaboration like it's a guarantee of success. You check the box, and you're good.
And thankfully, the counterargument just punctures that idea completely. You bring up the IBM Watson for oncology failure, which, had doctors from Memorial Sloan Kettering involved. The best of the best.
And then you have the COVID-19 prediction models, guided by top epidemiologists, and still, many of them were wildly inaccurate.
So the weakness here is that the piece doesn't really grapple with the fact that expertise, even world-class expertise, can just completely collapse when a system is chaotic or nonlinear.
Or when the experts themselves are dealing with something totally new.
Exactly. You have to acknowledge that experts bring valuable knowledge, but they also bring their own models, their own assumptions. And in a truly chaotic AI environment, those assumptions might be irrelevant, or worse, actively harmful.
So the big pivot we're recommending is to move the focus. Stop treating expert collaboration as just a box to check.
Right.
The suggestion for improvement is to shift the discussion from ensuring experts are in the room to actively defining the limits of their knowledge in the AI's design.
You need to ask, when is that expertise reliably predictive? And when does it just fall apart?
So, for example, interpreting a standard medical image. That's a known, predictable process.
A clear success case, it relies on codified knowledge. But that same collaborative model is often totally insufficient for predicting something dynamic, like a pandemic spreading.
Or a complex, personalized cancer response.
In those failure cases, the experts are navigating the unknown just as much as the algorithm is.
Okay, I hear that distinction. But what does designing around the limits of human knowledge actually look like in practice? You mention uncertainty modeling in the piece, but is that practical?
It's a challenge, for sure.
Does that mean you have to force experts to put a confidence score on every single input? That sounds like a massive operational headache.
It is a challenge, but the cost of not doing it is a failed system. And we're not necessarily talking about manual scores on every single data point. We're proposing a focus on building conflict resolution or uncertainty modeling into the design of the collaboration itself.
So into the framework.
Into the framework, you have to acknowledge that experts will bring different, often conflicting assumptions. The system has to be engineered to quantify that disagreement, not just paper over it with a consensus view.
So maybe it uses a different kind of modeling when it encounters something totally novel.
Perhaps it mandates Bayesian methods when it hits an unknown state, rather than just accepting the majority opinion as fact.
That's a powerful shift. So you're saying the failure isn't in skipping the expert, it's in failing to model the ambiguity that's inherent in their knowledge.
Especially in those chaotic domains. It moves the whole conversation from just relying on authority to actively building resilience against human uncertainty.
Which leads us to our last point, and it might be the hardest problem the material brings up: the black box.
Reconciling the demand for transparency with the technical reality of algorithmic opacity requires shifting focus from internal model explanation to external validation and outcome assurance.
The tension is set up perfectly in the paper. On one side, ethics demands transparency and explainability.
Of course.
But the counterargument correctly points out that most deep learning systems are, well, they're inherently unexplainable, the black box failures.
And the weakness is that the blueprint's answer to this, governance and accountability, is just too abstract. It doesn't solve the core technical problem.
Exactly. If the developers themselves literally cannot explain why the model did what it did,
Which you note in one of the examples.
then what good is governance that's based on auditing the code? It's reactive. It's useless. You can't audit something you can't see.
Right. The piece kind of gets stuck in that binary, explainable versus unexplainable.
So the core suggestion here is to propose a different solution entirely, one that focuses on auditing the outcomes rather than trying to audit the internal mechanics.
So you're saying we accept that true technical transparency is often just impossible with these systems.
For now, yes. And because of that, the piece should explore how to build rigorous, continuous external auditing of the system's impact and its behavior.
So you ensure it's meeting ethical outcomes, even if the process itself remains a black box.
This reframes transparency completely. It's a shift from algorithmic visibility to behavioral accountability.
You accept the black box.
You accept the black box, but you put it in a glass room where you can watch its every move in the real world.
Let's use the example from the piece to illustrate this, the hospital AI that had inequitable outcomes for black patients.
Okay.
Since you can't get technical explainability, the focus has to shift entirely to mandatory, real-time performance monitoring and bias assessment.
And that governance framework needs to have teeth.
It has to have teeth. It should be engineered to trigger an immediate model update or even a total shutdown if those equitable outcomes can't be demonstrated.
That makes the governance proactive. You're auditing for ethical results, not just ethical code. You demand action based on real-world impact.
And then you can contrast that with a classic failure like Google Flu Trends. The spectacular failure there wasn't just that its predictions went off the rails. It was a profound failure of continuous behavioral governance. The world changed, the data correlations it relied on broke, and the model wasn't governed to adapt its behavior.
There was no check against reality.
No check. Outcome-based governance would have demanded continuous calibration against actual CDC health data. It would have stopped the model from running wild based on its own faulty internal logic.
By making that conceptual shift from demanding internal clarity to demanding external behavioral compliance, you give a real actionable path forward.
You accept the technical limits and you engineer a smart governance solution around them.
And this is where the material can truly move into that advanced discussion. You're fusing the idealism of the blueprint with the hard reality of risk and opacity.
Yes.
Okay, so let's summarize the core takeaway here. This is a highly robust piece of work. It shows a real mastery of the principles and the critical realities. The next step is synthesis.
It's about fusing those two opposing ideas into one predictive model. And we've identified 3 major conceptual shifts for the rewrite.
Right.
1, build a predictive framework for failure. Don't just list what went wrong. Categorize it as structural risk versus process risk. That clarifies what's fixable and what just has to be managed.
2, you need to map the failure curve of human expertise. Refine the discussion by defining the limits of expert knowledge in these chaotic environments. And then build uncertainty modeling into your collaboration framework.
And 3, accept the black box, but hold its outcomes to account. Shift the entire focus of accountability from internal algorithmic transparency to rigorous external outcome-based governance.
Apply these insights, really work on that synthesis, and then submit the work back to us. We are genuinely excited to see this unified theory of trustworthy AI when you bring it back.